fires are a most terrifying and awesome phenomena. They are also a dismal statistic. Over 23,000 fires have raged through the forests of British Columbia during the last 10 years, destroying 5.5 million acres of trees. The value of timber burned in 1958 was over $8 million. In 59, over $2 million. In 1960, another $8 million. During the past 5 years, the BC Forest Services have averaged $2 million annually in firefighting costs. But this is not all. These millions do not reflect annual industrial losses, which include private firefighting costs, loss of production, equipment, bridges, and other transportation facilities. Even this is not the whole measure of destruction. There are no totals covering damage to watersheds, animal life, or the physical, chemical, and biological changes forced upon root and soil by the searing heat of a forest in flames. Many technological advances have been applied to the control of forest fires. High-speed pumps, bulldozers, ingenious hand tools, and radio all play a part in man's continuous war against fire. Now the aerial tanker has advanced the third dimension concept of attacking and containing fires. But every firefighter knows that a large forest fire is beyond human control by any means now known. The answer to control lies in the fighter's ability to hit the fire hard the moment it starts. These fire bombers have been called in to help contain a fire already well established. While the bomber can provide valuable support in this containment role, its real strength is its capacity to strike small fires the moment they are reported. It is hard to believe that this holocaust started from just a single flame and a few small puffs of smoke. Millions of acres of forest have been saved by the heroic efforts of the forester and his crews. They mount the ground attack and live in the lung-searing smog which hugs the ground for miles around. They eat, sleep, and work under the most difficult conditions. How do fires start? Over the past 10 years, campers and smokers have started well over 4,000 fires. Industrial and transportation operations have added to the toll. Lightning is the biggest single culprit, igniting over 5,000 fires since 1950. Whatever the reason, once started, fires must be fought using every means available to bring about control. Men and machines attempt to control the fires by cutting them off from the trees they consume. At times, the job seems hopeless. Wind, weather, and unlimited fuel can create fires of such magnitude that only a combination of natural forces have the power to put them out. One of these is humidity, another, rain. Wherever there are fires, hurried site conferences are held to meet the developing situation. Plans are made for the attack. This is war in plain geometry, length and breadth. Build a backfire, doze a fire break, stamp out the hot box, watch for crowning, bring in more equipment to support the ground fighters. Here is modern equipment to support the ground fighters. B-17s can drop 2,000 gallons of bentonite, water, or borate when and where it is needed. Avengers can support the ground fighters by dropping a 600-gallon fire-killing load when and where it is needed. Aerial tankers can add the third dimension to fighting fires. Speed is essential when tanking up. planes are quickly loaded and they return to the attack within minutes. The bomb load of water and bentonite is mixed in tanks which have been scooped out of the ground. The introduction of bentonite or borate reduces atomization and evaporation of water as it falls to the ground, which results in an increased concentration on the target. Other than pumps and hoses to handle the bentonite or mud, no special equipment is needed, which makes fire bomber operations extremely mobile and adaptable. B-17 tanks are filled with 2,000 gallons in just under 6 minutes. Avenger tanks are filled with 600 gallons in 4 minutes. All fire bomber tanks are fitted with large doors which permit instantaneous dumping of loads. Immediately the tanks are filled, the planes return to the air and the fire. But fire bombers cannot perform miracles. To prevent fires from spreading, they must be in a position to strike fast and hard the moment a fire is spotted. In addition to hitting fires as soon as they are reported, bombers can help ground crews fight well-established fires. Bombers can soak corridors for the movement of equipment through hot areas. They can subdue hot spots or flare-ups. They can cool down escape routes for men trapped behind the flames. When planes bomb a fire, what coverage can be expected? A bombing demonstration will best answer this question. The demonstration will be conducted over a target 425 feet by 150 feet with marking or measuring stakes 25 feet apart. The target forms a cross with an oil drum at its center, providing a point of reference for measuring the drop patterns and a bullseye for the pilots. Forestry officials and pilots inspect the target and discuss firebombing techniques. Test 1, Avenger, 600 gallons, height 50 feet. Test 1 repeated in slow motion. After each drop, officials inspect the target and measure drop patterns. Each test is recorded by a diagram. To evaluate the effectiveness of each test, the densities of bentonite dropped over the target are accurately measured and recorded. Measurement of test 1 shows that the area of heaviest concentration extends from 100 feet before the target center to 225 feet beyond, covering a section approximately 325 feet long by 75 feet wide. A light spray giving less concentration measures the full length of the target and is nearly 100 feet in width. The tremendous impact of the load dislodges the stakes, which are replaced after each test drop. Ordinary paper towels are used for measuring. Their discoloration indicates both the relative concentration and the pattern of the drop. Test 2, height 100 feet. The heavy concentration can be clearly seen in this slow motion record of test 2. Test 2 reveals a shrinkage in the area of heavy concentration. A fairly heavy density begins 75 feet before the target and extends 250 feet beyond. And a light spray area begins 250 feet before the target area. Test 3, height 150 feet. While increased atomization is evident, this slow motion record of Test 3 shows remarkable maintenance of concentration. The third test resulted in a small area of heavy concentration and a relatively good density, measuring 75 by 250 feet. The target bullseye lies almost on the center of the drop pattern, which attests to the accuracy of the Mudslingers. A B-17 loads up with 2,000 gallons of bentonite for the first of its tests over the target. Test 4, B-17, 2,000 gallons, height 50 feet. The impact is clearly shown in this slow motion record of the same test. Note the stake emerging at high speed. Measurements taken after the first demonstration drop by the B-17 reveal a much larger area of concentration than recorded during the Avenger tests. 3 fingers of almost 100 feet in length extend beyond the high-density area. Over 40,000 square feet of the target has been drenched. Test 5, height 75 feet. Which is more important, air tanker capacity or maneuverability? The answer is dictated by the terrain in which the fire is located. The pilot is flying slightly to the left of the target to compensate for wind. On impact, note the turf and stakes flying in all directions. Dropping from 75 feet, reduce the area of heavy concentration with a corresponding reduction in light spray. Test 6, Avenger 600 gallons, low pass over trees. The complete saturation achieved is illustrated in slow motion. Penetration is extremely good, soaking the tree trunks and the underbrush. Throughout the tests, 2 main points emerge. First, the lower the drop, the larger the area of heavy concentration. Second, fire bombers can hit targets with great accuracy. Test 7, Stearman, 100 gallons, low pass. High maneuverability permits this plane to fly into areas inaccessible to larger craft. Both concentration and accuracy are clearly demonstrated in slow motion. Watch the barrel. If strategically located before the fire season begins, fire bombers can strike fast the moment a fire is reported and help stop this destruction. The air arm can cool off hotspots so that men can work in safety. Build fire retardant lines. reduce the probability of crowning, knock down flare-ups, strengthen existing fire lines, fireproof local areas, support ground forces. How can this service be provided? By establishing fire bomber bases at 5 key locations: Victoria, Prince George, Prince Rupert, Kamloops, and Cranbrook, each controlling a radius of 150 miles. Auxiliary bases established at points beyond the 150-mile limit control their own outlying areas. When completed, this organization will cover all the main fire danger points in the province. Strike units at the main bases should include at least 2 Avengers, 1 patrol plane, a helicopter, and a mobile radio truck with other suitable equipment on call. To be effective, the organization must be ready before, not after, the fire season starts. Time is the important factor, and preparations made before fire takes hold will provide it. The air arm must be on a standby basis, ready to go into immediate action. Let's put this operation to work. Detection is the first vital step in the sequence of actions necessary to suppress fire. Light patrol planes maintain radio contact with the mobile headquarters. These planes have 5 main advantages over static observer posts. Aircraft fire detection is the most economical method of viewing large remote areas. They can see down through haze. Aircraft fire reports are precise. Aircraft are hired only when needed. While patrolling for new fires, they can report on known fires. Smoke sighted. The fire is checked and pinpointed. Headquarters contacted. Wind direction, availability of water, terrain, and type of fire are flashed to headquarters, which sets fire bomber forces in motion. Pilots check position on map. Alerted crews warm up Avengers. Ground crews already operating in the immediate area are alerted. First Avenger off and on its way. Helicopter with ground control personnel leaves for the fire site to build fire guards and direct the fire bomber pilots by radio. Second Avenger off. In minutes, all planes on duty at the base are airborne and converging on the fire. Hit them fast and hit them hard the moment they start. Hit them when they are small. What stand of green forest will join these black acres and add their wealth to the mounting totals of destruction? Without including industrial losses, over $25 million have been lost in timber and firefighting costs since 1958. Fire bombers can help, and their costs are small when compared with these annual material losses. Bombers, when properly employed, can add a third dimension to fighting fires and provide the forester with a hard-hitting air arm to support him in his continuing struggle to keep our forests green.